Okay, did you work on these before you found this answer key video? Good, let's talk. So they want me to find the other trig functions based upon having the cosine of theta. Remember, they said nothing about this being the unit circle, which means your radius is not equal to a 1. All right. Now I'm looking at on a restriction. I'm looking at the restriction they gave me. They said theta is between pi over 2 and pi. What does that tell you? Good. This restriction tells you that you're in quadrant 2, and in quadrant 2 your x's are negative and your y's are positive. Well done. Okay, so what does this tell you? It gives you x over r, so I know x is equal to -1 and r is equal to 3. Well, that's good. X had to be a negative, right? Remember, the radii are always positive. So in case you're like, well, why didn't I put the negative with the radius? The radius of a circle is always positive, right? Okay. And now you need the value for y. How are you going to find it? Pythagorean's theorem. So x squared plus y squared equals r squared. So x squared is just going to be 1. You're looking for y. R squared, 9. Got it. Okay, we're solving. It looks like we get y squared is equal to 8. And then y is equal, to the square root of 8. And it's either a positive or a negative answer. Yes? Okay, so you have to remember how to find the square root of something that is not a perfect square. And no, you can't use your calculator because it didn't say give them a decimal. So this is going to be either a negative square root of 2 or a positive square root of 2. Which of those two answers are we using? Well, the restriction says you're in quadrant 2. Y has to be positive, so this is my y value, a positive square root of 2 over 2. Good? Excellent. All right, now, cosine. You're like, they gave it to me. You're right, they did. I'm still going to write it down because I like my chart to be nice and neat. Sine, the y value over the radius. Tangent, the y value over, good, the x value. I guess we'll simplify that to negative root 2 times 2 times negative root 2. Or negative 2 root 2. Yeah, that's better. So far, so good with me? Excellent. Okay, now you need their reciprocals. So which trig function is a reciprocal of cosine? Secant. Now you know why I like to keep my chart nice and neat. I'm going to write this even though they gave it to me. Good, -3. When you flip this over, it's just -3. And the reciprocal of sine, cosecant, very good. 3 over 2 times the square root of 2. Now what? Multiply, right? You have to rationalize it. So tell me, you get 3 square root of 2. This is just a 2, isn't it? So wouldn't that just be a 4? Good, very good. And now cotangent. All right, over 1. Flip it over. -1, 2 times the square root of 2. You know what to do. We had to do that over there, didn't we? We had to multiply top and bottom by the square root of 2. And as I've mentioned before, write down that little step so you can see it. You know how visual you are. Okay, the numerator, negative square root of 2. Excellent. The denominator, yeah, you're going to get 2 times 2, because remember, that's just a 2, isn't it? Which means negative square root of 2 over 4. Good job, you guys. Is this making sense? The key is obviously understanding what they gave you in terms of the trig function. Did they give you x? Did they give you y? Did they give you r? And then the restriction. Sometimes the restriction is rather obvious, like they did in the lecture. It told me quadrant 2. Here it didn't come out and straight away say quadrant 2. They gave me the radian measurements that the angle was between. And sometimes they don't even give me this. They give me something completely different, something that I may consider an oddball. All right, well, I think those are coming up. Stay tuned. Okay, problem number 2. Did you get it? You think so? Okay, let's talk. So they tell me the cosine of theta is equal to a negative 1 over 4. Okay, got it. So I know, because I'm not on the unit circle, I know what? I know that x is negative 1, and we know r is 4. Excellent, which means we need to know y, right? So we have to find the y value. Got it. But they gave me the tangent of theta is greater than 0. Well, if it's greater than 0, that means it's positive. Okay, so here's the question. Which quadrants have tangent being positive? Remember, tangent is y over x. So would quadrant 1 give me a positive tangent? Sure, it would, because they're both positive. X and y are both positive, will give me positive tangent. How about quadrant 2? Nope, because x is negative, y is positive. That ain't going to give me a positive when I divide. How about quadrant 3? X is negative, y is negative when I divide. Good. Quadrant 3 also. How about quadrant 4? No, quadrant 4 is like quadrant 2. That's not going to happen. So here's the deal. I have 2 possibilities. And let me just write it down, right? They're both negative here. So you're like, well, which quadrant is it? Go back to what they gave you. They told you x was a negative 1, didn't they? Well, which one of these 2 quadrants has x being negative? Quadrant 3. So there goes quadrant 1. So you're in quadrant 3, which means your y value that you're about to find is negative. Okay, let's go find it. So we have x squared plus y squared equals r squared. X squared plus y squared equals r squared. Keep going. Okay, so we either get a negative square root of 15 or a positive square root of 15. Good. Which one is it? Based upon that, it's a negative square root of 15. Good? Excellent. Okay, ready to find those trig functions? I hope so. Let's see if my dogs agree. Can you hear them barking? Okay, so we have the cosine of theta. They already gave it to me, negative 1/4. Lovely. Sine of theta, what is it? Good, negative square root of 15 over r. Tangent of theta, y, negative square root of 15 over x, negative 1. So that's going to be a positive square root of 15, isn't it? Cool. Okay. Reciprocals, here we go. Good. Reciprocal, that is secant. So the secant of theta is, yeah, just negative 4. Reciprocal of sine. Cosecant. Good. You know, are they ever going to give me a time where I'm not going to end up with a radical in the denominator? Usually we end up with radicals in the denominator. Well, c'est la vie. Okay, so you know how to rationalize as well as I do. Multiply top and bottom by the square root of 15, right? Does that make sense? Good. And last but not least, cotangent. Oh, that's over 1, isn't it? By the way, tangent was supposed to be positive, yes? Wasn't this a positive answer? Woohoo! Loving it. Okay. 1 over square root of 15. And again, rationalize it. You know what to do. Good? Excellent. Got another example coming your way, so stay tuned. So let's look at problem 3. Tell me what you did. You're like, okay, we have a cotangent of theta equals 4 over 3. I know we're not on the unit circle because I didn't say it, so r can't be equal to 1. So what did the cotangent of theta tell you? All right, it told you that you know, cotangent is x over y. So you know x equals 4 and y equals 3. So what do you know you've got to find? Yeah, you've got to find r. Okay, got it. But what else did it tell you? It told you the cosine of theta is less than 0. Well, if it's less than 0, that means it's negative. Excellent. So which quadrants have cosine being negative? Good. So we have quadrant 2, because remember, cosine is associated with x. So the x has to be negative. So that's in quadrants 2 and 3. Okay, got it. Tell me what we know about the point in quadrant 2. That is a negative x and a positive y. Got it. Tell me what you know about the point in quadrant 3. That's a negative x and a negative y. Got it. So you're like, well, which one is it? Okay. Go back to what you know about cotangent. Cotangent's a positive answer, isn't it? X is positive and y is positive, right? Cotangent's x over y. If I take x over y in quadrant 2, does that give me a positive answer? No, it gives me a negative answer. In quadrant 3, if x is negative and y is negative, that means I get a positive answer, right? Right. So you're like, well, wait. That means x is negative and y is negative. It's exactly what that means. X is negative and y is negative. Are you with me? Good. Excellent. Because negative divided by negative is positive. Good job. Does that make sense? Great. Find r. By the way, is r going to be positive or negative? Right. R is always positive because it's the radius. Okay, so x squared plus y squared equals r squared. X squared, so that's 16 plus 9 equals r squared. We have 25 equals r squared, so r has to be the positive 5, right? It can't be the negative 5. Good? So positive 5 for the r. Got it. Does it make sense, based upon this restriction and what we knew about cotangent, does it make sense that we are lying in quadrant 3 or that theta is in quadrant 3? Great. And if you're like, can we do that again? Rewind the video, go listen to it again, pause it where you need to, make your notes, make sure you're on the same page I am, and then hit play again. Cool? Okay. So, cosine. Okay, cosine of theta. X over r, so we have a negative 4 over 5. Sine of theta. Y over r, so we have a negative 3 over 5. Tangent of theta is y over x, so you have a negative 3 over a negative 4, which is a positive 3/4, right? Okay. Oh, by the way, if cotangent is positive, should tangent be positive? Because they're just reciprocals of each other. Got it. Good. Secant is the reciprocal trig function to cosine. Negative 5 over 4. Cosecant is the reciprocal trig function of sine. Negative 5 over 3. Cotangent is the reciprocal trig function of tangent. This was 3/4. This is 4/3, which is exactly what we had to start with. Good? Getting the hang of it? Excellent. Problem 4, coming your way. Okay, problem 4, tell me what you did. You saw we had the tangent of theta, and it was a negative 1 over 3. And you knew tangent was y over x, so we know that x equals 3, y equals 1, and you're like, well, which one does the negative go with? Because the negative could go with either one. You're right, it could. So hold that thought a second. I'm just going to kind of remind myself. And you're going to need to find r, aren't you? Okay. What does this restriction tell you? The sine of theta is greater than 0. That means it's positive, isn't it? Okay. So sine of theta, which variable is associated with sine? The y's. That means the y's have to be positive, which tells you that negative has got to go with the x first and foremost. So you kind of have an indication of what's going on over there. So sine is positive in which quadrants? Quadrant 1 and quadrant 2. Quadrant 1, x and y are both positive. Quadrant 2, x is negative, y is positive. Can it be a quadrant 1 theta? No, because I already figured out that x had to be negative given the y was positive. So it can't be quadrant 1. So it has to be, theta has to be in quadrant 2 where x is negative and y is positive. So this just confirms the process, my thinking process here. Good? Okay, gotta find r. So, Pythagorean's theorem, x squared plus y squared equals r squared. So you have 9 plus 1 equals r squared. 10 equals r squared. R is equal to a negative square root of 10 or a positive square root of 10. Which one? Positive, because it's the radius. Great. You guys are doing excellent. Is this making sense? All right. So, ready? Tell me what you wrote. Cosine of theta. You said was x over r. Problem number 3 had no roots in it, did it? Well, I guess problem number 4 is going to make up for it. No problem. Negative 3, square root of 10 over 10. We got this. Sine of theta. Y over r. Rationalize again. Square root of 10 over 10. Tangent of theta. Let's see. Tangent is y over x. Which is what we have, negative 1/3, isn't it? I can put the negative up on the numerator. Let's get rid of it from the denominator. Good? Cool. Reciprocal is secant. Okay, so now remind me, what are we going to look at to reciprocate? The initial writing of cosine or the rationalized form of cosine? Which one's easier to flip over? Yeah, the initial. I agree. So it's a negative square root of 10 over 3. Good. Reciprocal of sine. Cosecant. Okay, so which one are you going to look at to reciprocate? The initial writing or the rationalized form? Which one's easier to flip over? Yeah, the initial writing. So that's just going to be the square root of 10, isn't it? Cotangent. Yep, just negative 3 when you flip that over. Loving it. You guys good with this? Is this making sense? Awesome. Okay, hopefully you had fun with this. Hopefully this makes sense. I have some more examples coming your way if you need extra practice. And if you're like, no, I'm good, great. But if you do need the extra practice, please make certain you work on them before you find my answer key video. Catch you guys on the flip side.